Evening, everyone, and tomorrow is watching. My name is Dataset Shali, and I'm a master's student at Macquarie University, taking courses by doing programming computer science, and this is a course to do with data visualization. So today I'm going to be visualized a water data set that was collected in different parts country, Uganda, in different districts, as we are going to see. And this analysis was done using the d3.js library. So starting with what is d3.js? Yes, so it stands for a short, d3.js is a short form for data-driven document, and it's a popular JavaScript library that is being used currently in visualizing and manipulating data in web standards such as HTML, CSS, and SVG, and provides it's a powerful tool for binding data to the documents of that DOM. So d3.js allows you to code your data and produce final visualizations as you want them. And it also gives you provisions and customizing the data as you would want it to be customized or presented. So today, like I said, I'm going to do data visualization of this water data set that was collected the different parts of the country Uganda, from different districts, as you can see here. We have Chinja, Puchiri, Iganga, as you can see the name of the districts there. And it was still collected from different villages, and all that was captured. So we see that most of the data was collected from Lamu district, because from Lamu district, a total of 35 villages were gone to collect the information from there. And the least amount of data was collected from Mubende, where we see only two villages from which, or two data rows from which Mubende, from which that was got from Mubende. So as we proceed, you are going to, I did quite a number of visualizations, but due to limited time to actually do this, so I'm only going to present it. I hope it gives us some insights about the data that we have. So this is a scatter plot showing the relationship between turbidity and quality of the water. So from this data set, we can determine if the water is drinkable, depending on the pH, how high the pH is, the electrical conductivity, the turbidity, the quality, a lot of things that can help us determine this. From this, we can see we have outliers here, and they are quite low. Quality is high and turbidity is low, more on the edge. So it's around 2. So this water is okay, and this is general. It is data that was collected general, like for all districts. Yeah, I'm analyzing for all districts. So these outliers most likely may be Lamu, because it had the highest number of places to which the data was collected. And maybe these ones there where I call it low, but I would say that most of the water is good for human consumption. So I wanted to further analyze this data in terms of the districts. How high is stability in a particular district, or how high is the electrical conductivity? But like I said, I cannot present all the visualizations here. So yeah, we see here these are villages in Chinja. We see that the stability in Chinja is and Mauta has the highest, roughly around maybe like 6.2, 6.3. And from my understanding, acceptability is low and not more than 5. That is good water for consumption. That goes, the same goes for villages in Lamu, and we can see that it has really quite a high number. So cannot be of them have a high number. Probably that will help us to know if we can, maybe tap safe water sources for these people in these places. And then I went further to do stability by district. So here I'm trying to show how high is stability in a given district. And then we do have, we can see Ginger, and of course, the districts actually here with the highest stability, we can see Lamu because of the other factors that attribute to it, the fact that it was collected from many places other than the rest of these districts. And also we saw that some of these districts, like how we can see that, like Mwenge and Nakaseke, they collected a lot of data from there. So but if you look here, so Kamenge is also high, and Nakaseke is quite low, meaning for it stability in that area is low as opposed to to other districts. So I would have loved to do this for all of the properties that we had, the different attributes, but due to the limitation of time and the presentation is timed, I cannot really show everything. So this is sort of like a summary, but in future I hope to do like all of it, the whole data set, and to go into the critical and the smallest bits to further understand which regions are prone to having impurities in the water and rendering this water, non-drinkable and not good for human consumption. And so that they need maybe boreholes set up for them, safe water sent to them. And that can be determined by the attributes of water that were collected, like I mentioned earlier. That is electrical conductivity, turbidity, quality, there is phosphates, nitrites, nitrates. All those do help us in achieving that. And there is also pH, So we all know that a higher pH is not really good. It's sort of, as long as the pH is higher than 6, like this, 7, it's not good. But this is a total of all the villages that we're going to. So I may not be, this may not be conclusive, but if we go further into determining pH of a particular pH of a particular village district, like with stability, I'm sure we can tell which one, which villages or which districts are more prone to, that have bad water sources. But like I said, due to time, all of the visualization was one here. I didn't do them here, so this is just but from what I can tell, districts like Lamu, districts like Mukono and Kamwenge, they do have their water sources are not really so much of healthy for the people in those areas, and they need to be worked on to provide the water sources to them. Thank you.